Hi, in this lecture, we're going to discuss one of the important integration techniques, the integration of the rational functions. Before we start, we have to first of all define what is a rational function. We call the function as a rational function if we have the fraction of the two polynomials. For example, p of x divided to the q of x, where the p of x is going to be the polynomial of power n, and the q of x is going to be the polynomial of power m. What does it mean, the polynomial of power m? So it means that p of x is written as the sum of the powers of the x, basically some constant an multiplied to the x in the power of n plus another constant an minus 1 multiplied to the x in the power of n minus 1 plus and so on plus a0. And the q of x is written similarly. So another constant bn, for example, multiplied to the x in the power of m plus bn minus 1 multiplied to the x in the power of, m minus 1 plus and so on plus b0. So we call this as the polynomial of power of n. This is going to be the polynomial of power of m. For example, if I write down the x squared plus 3x plus 1. So we all know that this is quadratic function. And at the same time, this is the polynomial of power of 2 because the highest power of the x is equal to the 2. It is possible that you can write this as, like, for example, x cubed plus 100 of x plus 5, for example, right? Again, it doesn't matter what are the coefficients before the x's. So we always look to the power. Basically, there's the highest power of the x. So in this case, the highest power of the x is equal to the 3. So that is why we call this polynomial as a polynomial of power of 3. So let's assume that I've got the fraction of the two polynomials. Polynomial of power of n divided to the polynomial of power of m. So in general, it is going to be written like this formulas. The first thing which we have to do before we start learning the integration, we have to make sure that the polynomial on the numerator on the top has smaller power than the polynomial on the bottom, on the denominator. Basically, this polynomial should be smaller than this one. Only in this case, we can apply the integration techniques for the rational functions. What if the polynomial here on the numerator has higher power than here? Then in this case, we have to try to divide them. For example, I've got this polynomial p of x in the power of 3, right? So the x cubed plus x, it is the polynomial of power of 3. And on the denominator, I've got the polynomial x minus 1, which is the power of 1. So the polynomial on the numerator is has greater power than the polynomial on the denominator. So if you have this case, you have to divide them so that the polynomial on the numerator should always have smaller power than the polynomial on the denominator. If you don't know how to divide them, please refer to our another video to learn how to divide the two polynomials. Let's assume that we know how to do this. And for example, I can divide x cubed plus x to the x minus 1. So the basic idea is very similar as we've learned the division in the school. Like, I need to try to get rid of the highest terms here. So what I need to multiply here to the x minus 1 in order to get rid of the highest term x cubed, x squared, right? If I multiply the x squared to the x, it's going to be x cubed. If I multiply the x squared to the minus 1, it's going to be minus x squared. So now I have to subtract them. If I subtract, what I will get is x cubed plus x minus x cubed plus x squared. It's going to be x squared plus x. So now I need to get rid of the x squared. So what I need to multiply here, plus x. So if I multiply the x to the x minus 1, it's going to be x squared minus x. If I subtract, it's going to be 2x. So still, I need to divide this term to this one. Can I do this? So the polynomial, so 2x is a polynomial of power of 1. X minus 1 is also polynomial of power of 1. If the two polynomials have equal powers, we can still divide them. So in order to divide them, I need to multiply here some number. For example, 2, right? If I multiply the 2 to the x minus 1, it's going to be 2x minus 2. If I subtract, it's going to be equal to the 2. So now this 2 is the polynomial of power of 0, and x minus 1 is the polynomial of power of 1. So it means that I can't divide this anymore. Okay, so we have to divide the polynomials until the power of the numerator is going to be smaller than the power on the denominator. So what I can do with this case is that I can write as x cubed plus x divided to the x minus 1 is equal to x squared plus x plus 2. This is what we have divided, right? And plus, what is the remainder is 2 divided to the x minus 1. So 2 is our remainder. So in general, we need to always divide the polynomial on the numerator to the polynomial on the denominator if the power on the numerator is higher. Okay, so after we've got the higher power, so the smaller power on the numerator, you have to do something. So before we start learning, so before we proceed, so let me remind you how we usually added and subtracted the fractions. If I've got the two fractions, in this case is a 1 over 2 and 1 over 3, we are able to add or subtract them only in a case if they have the common denominator, right? If don't, then we have to force them to make the common denominator. Basically, I need to multiply this fraction to the 3. This fraction should be multiplied to the 2, so that it's going to be 3 over 6 plus 2 over 6, right? They are the same as the original ones. It's going to be equal to the 5 over 6. Good, so this is how we need to add or subtract the two fractions, which is more or less easy. But the problem is like this. So if you have the two fractions, it appears you need to give the common denominator in order to get 5 over 6. What if you have the 5 over 6? Okay, it's going to be like a one fraction, which is kind of more complicated than the original ones. What if I would like to write this, so 5 over 6, let me write this. 5 over 6 is given. I would like to write this as the sum of the two other fractions. So this is our goal. So can I do this? So in this case, you might guess that this is going to be equal to the 1 over 2 and 1 over 3. But in general, we need to learn some algorithms or the guides how to do this. So if you're given one fraction, how to split this into the two. Okay, so this is our basic idea. So if we are given some rational function, here in this case, the power of the numerator is equal to the 1, right? And the power of the denominator is equal to the 2. Is it the power of on the numerator is smaller than the power on the denominator? It means that we can proceed. Now our idea is like this. So I've got the fraction, right, which is like complicated fraction. I would like to split this into the 2, okay, so that the sum of that 2 is going to give me this one. For example, I can split this fraction x plus 5 over x squared plus x minus 2 to the 2 minus x minus 1 over, so 2 over x minus 1 minus 1 over x plus 2, it appears. Okay, that integrating, so if I would need to integrate this one, it is going to be equal to the integration of this one minus the integration of this one, and integrating two others is going to be easier than the integrating of the original one. So this is our goal. So if I've got the complicated 1 ratio, I would like to split this into the 2, into the 3, and so on. Then the only problem is how to do this. So the first of all, let us verify whether this is equal to this one. In order to do this, we need to give the common denominator, right? So this ratio should be multiplied as x plus 2. This ratio should be multiplied as x minus 1. If we give the common denominator, it's going to be 2x plus 4 minus x plus 1, right? So divided to the x squared plus x minus 2. So I'm multiplying x minus 1 to the x plus 2. It's going to be x squared plus x minus 2. So if I simplify everything on the numerator, it's going to be x plus 5 divided to the x squared plus x minus 2. So this is essentially our original ratio. It appears we can split them into the 2. Well, in order to split any rational function into the 2 or into some parts, it appears, it's very important to look onto the denominator. So it really depends on the denominator. If it is possible to write down the denominator as a multiplication of the linear terms, as in this case, as a multiplication of the x minus 1 multiplied as x plus 2, then we need to apply one algorithm. If it is not possible to do this, we need to apply to another algorithm and so on. So we are going to consider all the cases one by one. So we're going to start from the case when we are able to split the denominator onto the linear factors. So let's assume that you are given the fraction, so the rational function where the denominator x squared plus x minus 2 can be written as the multiplication of the x minus 1 multiplied to the x plus 2. So what we need to do is, we need to always assume that, hey, if it is possible to write this, then I can write down this one rational function as the sum of the two, where first one is going to be some constant divided to the x minus 1. Second one is going to be another constant divided to the x plus 2. So the only question is, what are those constants? So we know that they are 2 and minus 1 from the previous example. So now let's learn the algorithm how to find the value for the a and value for the b. So it appears if I would like to find the value for the a and b, I need to give the common denominator and find the form on the numerator. So basically, I'm going to give the common denominator. So this part should be multiplied as x plus 2. And this part should be multiplied to the x minus 1. So let me give the common denominator. So it's going to be ax plus 2a plus bx minus b. So this is divided to the x minus 1 multiplied to the x plus 2. And again, we can write this as so let me write down the terms with the x. That's going to be a plus b. And the terms without the x, it's going to be 2a minus b, and this is divided to x minus 1 multiplied to the x plus 2. So what we've started with, that this polynomial is equal to this polynomial actually, right? So this is what we've started. So we've started from this one, x plus 5 over this term is equal to this term, it appears. And if these two rational functions are equal, then the polynomials, their numerators and denominators should be equal as well. So we can see that their denominators are the same. So we just need to equalize their numerators. So well, these two polynomials, x plus 5 and this one, are equal if and only if the coefficients before the x and the free coefficients are equal correspondingly. So what is the coefficient before the x here? So this is equal to the 1, right? And what is the coefficient before the x here? It's a plus b. So the a plus b should be equal to the 1, okay? Because the corresponding coefficients of the two polynomials should be equal. So what's a free coefficient here? So free coefficient means the term without the x. So in this case, it's equal to the 5, right? What's a free coefficient here? It's 2a plus b. So 2a plus b, sorry, minus b should be equal to the 5. So, well, I've got the system of the two with two unknowns, a and b, and two equations, so I can solve this. So if I just simply add them, it's going to be 3a, right, is equal to the 6. It means that a is equal to the 2. If I substitute the a is equal to the 2 to the first equation, it's going to be 2 plus b is equal to the 1. It means that b is equal to the minus 1, right? So it appears a is equal to the 2, b is equal to the minus 1. This is exactly what we knew before, right? Do you remember here? So the a is equal to the 2, b is equal to the minus 1. Well, so this is the algorithm how to deal with this. So if the denominator can be split as the multiplication, can be written as a multiplication of the linear factors, linear terms, then we need to write down this always like, hey, the first linear term, like some constant divided to the first linear term, plus another constant multiplied to the second linear term, and so on. We give the common denominator, we bring this to some polynomial, we equalize this to the original numerator by coefficient wise, bring the system of linear equations, and by solving the system of linear equations, we're going to find all coefficients. Well, in the slides, I have the more beautiful form of writing all of these things, but essentially you're going to have the same thing. So let's do an example. So I've got this integration. Okay, so I need to integrate this. So the first of all, if you remember, I can write this in the terms of the as a polynomial. So our polynomial is 1 over x squared minus 4. So what's the power of the numerator? It's 0, right? It's a polynomial where the highest power is 0, and the power of the denominator is equal to the 2. Okay, so it means that 0 to the numerator has the smaller power, so that is why we can divide. So the first thing which we need to do is we need to know whether it is possible to write down the denominator as a multiplication of the linear term. So, well, you need to be experienced in order to be able to do this. So you need to know that, for example, x squared minus 4 can be written as the x minus 2 multiplied as x plus 2. If you don't know how to do this, then you need to be able to find the roots, for example, of the quadratic equation, and so on. For example, in this case, I can write down this as the 1 over x minus 2 and multiply it as a x plus 2. So if you remember, so if it is possible to write down the polynomial as a multiplication of the linear factors, then we need to always write this as some constant divided to the first linear factor, x minus 2, plus another constant divided to the second linear factor, right? Okay. Then our goal is to find the values of these constants. What's a and what's a b? In order to do this, we need to give the common denominator. So sorry, so you probably don't see anything here. Let me write this here. So the 1 over x squared minus 4 can be written as the 1 divided to the x minus 2 multiplied to the x plus 2. It's going to be written as the constant divided to the x minus 2 plus another constant divided to the x plus 2. So in order to find the values of the constants, I need to give the common denominator here to be equal to the x plus 2. This one is going to be x minus 2. If we give the common denominator, it's going to be ax plus 2a, right? So plus bx minus 2b. And this all should be equal to, so basically I give the common denominator here, right? So I added these two fractions. I've got the numerator, which is going to be equal to this one. And this should be equal to the 1, right? So let me write down, or let me simplify this. First of all, it's going to be, I'm going to write down always the terms in terms of the polynomial, basically in terms of the x squared, x, and so on. So in this case, I just need to write this x multiplied to the a plus b plus the free coefficients in this case is going to be 2a minus 2b. Okay, so this should be equal simply to the 1. Okay, so to this 1. Because two numerators should be the same. So as you remember, so two polynomials are the same if their corresponding coefficients are the same. So what is the coefficient before the x here? So there is no x, it means that it's equal to the 0, right? It means that coefficient before the x here, which is a plus b, should be equal to the 0. So the a plus b is equal to the 0, right? And 2a minus 2b is equal to what? To the 1, which is the free coefficient here, right? So the term without the x is equal to the 1. Okay, so we just need to try to solve this. So I'm going to just multiply everything to the 2, or I can divide everything to the 2 on the second one. So let me multiply everything to the 2 here. 2, it doesn't matter because I can do this. Now we can just add everything up. If I add them, it's going to be 4a is equal to 1. It means that a is equal to the 1 over 4. And if I substitute this to any of the equations, I can find that the b is equal to 1 over 4 also. So the integration of x squared, or of 1 over x squared minus 4 can be split to the 1 over 4 divided to the x minus 2 plus b, where like minus 1 over 4 divided to the x plus 2. So here I have like more fancy way of all of the things. Here I can split this integration to the 1 over 4 divided to the x minus t plus minus 1 over 4 divided to the x plus t. So the integration of the first term is going to be simply ln of x minus t multiplied to the 1 over 4. Integration of the second one is going to be ln of x plus t multiplied to the 1 over 4. So this minus 1 can be, we can write this in terms of the power of the x minus x plus t, right? Okay, so this is the case number 1 actually. So the case number 2 is that the factor, so the denominator can be written as the linear factor. So what to do in that case? So for example, so some of the factors of the denominator are repeated. For example, you can write down the denominator as the x minus 1 multiplied with x plus 1, but the x minus 1 is repeated twice. So basically, x minus 1 multiplied with x minus 1 multiplied with x plus 1. So in this case, we can't do this as the same way as we did before. So we need to do something different. So it appears if some of the factors on the denominator are repeated twice, 3 times, and so on, then we need to write them in this way. So again, so the coefficient, some constant divided to the first term. So another constant divided to the first term in the square plus the coefficient divided to the second term. What if the first term has been repeated 3 times? Then I would need the 3 terms just to write down the first term only. Okay, so depending on the number of the repetitions, we are going to need this number of the terms here. So if the x minus 1 is repeated twice, then I'm going to need 2 terms on the right hand side to write this. Okay, then how to find, so our goal is again to find the a, b, and c. In order to find them, we are going to basically do the same thing as we did before. Give the common denominator, equalize the polynomials by coefficient wise, and find the a, b, and c. So let us give the common denominator. So in this case, it's going to be, so the first term should be written multiplied as the x minus 1 multiplied as the x plus 1, right? So the second term should be multiplied as the x plus 1 only. The last term should be multiplied as x minus 1 in the square. So our common denominator should be x minus 1 in the square multiplied as the x plus 1. So I'm not going to write down the denominator because the denominators are going to be the same in both of the cases. I'm just going to write down the numerators. Then in the first case, a is going to be multiplied to the x squared. So I'm going to open the brackets right immediately. If you open the brackets, it's going to be x squared minus 1, right? So the plus b multiplied to the x plus 1. So plus c multiplied to the, plus c multiplied to the x squared minus tx plus 1. So I'm going to open the brackets and write down the terms separately. So if I open the brackets, it's going to be ax squared minus a plus bx plus b plus cx squared minus 2cx plus c. So what we have to do is we need to write down the terms with the x squared separately, the terms with the x separately, and the terms without any x separately. Okay, so we are going to write it. So the x squared is going to be written as the a plus c plus the terms with the x is going to be x is going to be b minus 2c, and the rest is going to be b plus c minus a. So this is what we have here actually, and this should be equal to the 4x, right? So if you can equalize this the polynomials, you need to equalize their coefficients. 4x is a polynomial, right, with power of 1. But if you assume that this has the x squared term as well, then the coefficient before the x squared is equal to the 0. So if we multiply the 0 to the x squared, so that's why we don't have this. So the 0, the coefficient before the x squared here, and the coefficient before the x squared here is equal to the a plus c. So the coefficient before the x is equal to the 4 here, so the coefficient before the x here is b minus 2c, right? And the free coefficient again is 0 here, right? There is no free coefficient. The free coefficient here is equal to the b plus c minus a. Okay, so I've got the 3 equations and 3 unknowns, and I can find their values. By finding their values, we can solve this integral equation. So let's find this. Okay. For example, we can find a from the first equation, which is going to be equal to the minus b simply, right? So let's substitute this to the last equation. That's going to be b minus 2c is equal to the 4. It's a second equation. If I substitute the first equation to the last one, it's going to be 2b plus c is equal to the 0, right? A minus a is going to be substituted with the minus b. It's going to be plus b. With this b, it's going to be 2b plus c, okay? So the last 2 equations depend on the 2 variables only, right? So I can multiply the second equation to the 2 and add this to the, so the last equation, the third equation to the 2. If I multiply this to the 2, it's going to be 4b plus 2c. It's equal to the 0. The second equation is going to be equal to the b minus 2c is equal to the 4, right? If I add them, so the 2c's is going to be like a cancel with the 2c, and I will have 5b is equal to the 4, right? So the 5b is equal to the 4. From here, we can find that the b is equal to 4 over 5, sorry. 4 over 5. What's the value of the a? A is going to be equal to the minus 4 over 5. And the value of the c can be found from here, for example. So the 2c is equal to the b minus 4. So the 2c is equal to the b minus 4. So since we know what's a b, which is 4 over 5, it's going to be 4 over 5 minus 4. It's going to be 20 minus 16 over 5. So this should be divided to the 2. So c is equal to the minus 8 over 5. So these are the values of the a, b, and c. So let's check whether this is true. Okay, so once we found them, right, we can try to integrate them. Okay, so integration, all of these terms is more or less straightforward, right? So please refer to our other videos how to integrate this kind of polynomial. So basically 1 over x minus 1, its integration over some constant divided to the x minus 1 is going to be the ln of x minus 1. This is very simple to integrate. So the integration of b of x minus 1 in the power of minus 2 dx is going to be b multiplied to the x minus 1 divided to the minus 1, right? So we just add the 1 to its power and divide this to the power plus 1. Okay, and there is a case number 3. And the case number 3 is some of the terms on the denominator can be irreducible. So can be irreducible. What does it mean? It means that we can write down the denominator as a multiplication of the linear terms. For example, x squared plus 4, it doesn't have the roots, right? So basically, you can write this as a multiplication of the linear terms. Linear term is simply with the x. Highest power is equal to the x. So what to do in this case? If you have this kind of form, then we are going to write down this as the sum in this case. So the linear term is always going to be written as some constant divided to this linear term. So this term, which is not reducible anymore, it has the power of 2. So it should be written as some polynomial of power of 1 divided to this polynomial, to this polynomial of power of 2. So since it is irreducible, then its numerator should be not just a constant anymore. So it should be some polynomial of power 1 less than the denominator. So in this case, it's going to be simply of power of 1. So again, we need to find the a, b, and c by giving the common denominator. So we multiply the first term to the x squared plus 4. So the second term should be multiplied to the x, right? So let's multiply the first term to the x plus 4. It's going to be ax squared plus 4a. Plus the second term is going to be multiplied to the x. It's going to be bx squared plus cx, right? So I'm going to write down this in terms of the polynomial. It means that I'm going to write down x squared terms separately. It's going to be a plus b, right? So the plus x term separately, it's going to be cx, plus the free coefficients separately, 4a separately. Then I'm going to equalize this with this one, right? So what is the coefficient before the x squared here? It's equal to the 2, right? So the 2 should be equal to the coefficient before the x squared here, which is equal to the a plus b. So what is the coefficient before the x? It's equal to the -1. This should be equal to the coefficient before the x cubed, which is equal to the c, right? And the coefficient before the free coefficient is equal to the 4, right? And this should be equal to the 4a. Okay, so from here, which is very simple to find that a is equal to the 1, c is equal to the -1, b is equal to 1 as well. Good, so we can now integrate this. It's going to be the integration of the 1 over x dx plus the second term is going to be the integration of x plus or -1 in this case, right? So the x minus 1 divided to the x squared plus 4, okay, dx. Okay, the first term is very simple. It's going to be simply ln of x, right? And the second term is slightly difficult because you need to write this again as the sum of the two other integrations. It's going to be x divided to the x squared plus 4 dx. Then you need to use the substitution rule here. Substitution. So basically, you need to divide substitute x squared plus 4 as a u. Then the u is going to be 2x dx, right? Which you can find here on the denominator. And the last term is going to be plus the integration of the, so sorry, in this case, it's going to be minus the integration of the 1 over x squared plus 4 dx, and it's integrate. So you need to use the formula of the arctangent. So the integration of this term is going to be arctangent of x over 2. There is a formula. Okay, so let's summarize everything. So we start again from the rational functions. So I've got the rational function. If the polynomial on the numerator has higher power than the polynomial on the denominator, we have to divide them first of all. So if no, then we need to go to the second case, or the first case in our case. It's going to be if the denominator can be written as a multiplication of the linear terms, then split them. Try to split them as some constant divided to the first linear term plus another constant multiplied divided to the second linear term, and so on. The case number 2 is when some of the linear terms are repeated. Then you need more terms in order to write down, in order to split the denominator, right? And the last case is when the q of x is irreducible, basically, so some of the terms cannot be written as a multiplication of the linear terms. Then you need to write down those terms, those factors, not just constant divided to that factor, but some polynomial divided to that factor. For example, if you have got x squared plus a, which is irreducible, right? Then you need to write down this as the polynomial of power of 1 divided to x squared plus 8, basically px plus c divided to the x squared plus 8. So this is basically the guidelines how to integrate the rational functions.